In this segment on fractions, we're going to be talking about comparing fractions, so relative to each other. One of the big ideas in mathematics is that when we're doing adding or subtracting, we have to have the same kinds of things. I can't add different kinds of things to get a total. So I need to have the same kinds of things. The same thing holds true when I'm comparing. I need to be comparing the same kinds of things. So it's important for us to make sure that when we're talking about fractions, we have to have something that's the same kind of thing. Now normally we talk about having a common or the same kind of denominator, but I want to take a couple of minutes and show you that we can also compare fractions as long as we have the same kind of numerator as well, which is a little different way of doing it, but I want to show the value of doing both ways. So here I want to compare 1/2 to 1/5, and I want to make sure that we understand that we've got something in common already. We have 1. 1 is how many pieces we have. And the bottom number, as I said before, is the number of pieces it's cut into, or I like to think of it as what size they are. So if I have one whole circle, so here's my one whole circle, and I'm going to cut that whole circle into 2 pieces. So each piece would therefore be called 1/2, so I have one of size 2. If I take that same circle and I cut it into 5 pieces, each piece is going to be that size. So here's my 1/5. And students very quickly see that the blue one's bigger than the red one. So 1/2 has got to be bigger than 1/5. And so 1 of a big piece versus 1 of a small piece. Pretty straightforward. The blue piece, the big piece, is bigger. So as long as I have the same amount of things, I have one of both, I can figure out which one's going to be bigger. And it doesn't just work when the number on the top is a 1. If I have 2 of size 2 and I have 2 of size 5, 2 blues are still bigger than the 2 reds, and therefore 2 over 2 is bigger than 2 over 5, or 2/2 is bigger than 2/5. Another way we can compare, as long as we have something that's the same, in this case we have the denominator is the same. The number on the bottom is the same, and that tells me what size pieces I have. So if I have 1/4, if I take my 1 and I divide it into 4 pieces, there's one of those. And over on the other side, if I had 2 of those, a student could very easily see that I have 2 of these versus only 1 of these. This one's way bigger. So again, as long as something is the same, in this case, as long as my denominator is the same, I'm talking about fourths here, and I'm talking about fourths here. I've taken my circle, I've cut it into size 4 pieces, and I have one of them. I've cut my circle into size 4 pieces, and I have 2 of them. So I have 2 of the same size pieces. I have a lot more. I've got twice as much as this person does. So again, as long as something's the same, in this case the denominator is the same, it's easy to recognize which one's which one's bigger, which one's smaller. So now we've talked, if the numerators are the same, it's fairly easy to tell which one's bigger, which one's smaller. If the denominator's the same, it's fairly easy to tell if which one's bigger, which one's smaller. But what happens if the numerator and the denominator are not the same? That's somewhat more problematic. Before we get into a more complicated, advanced way of talking about equivalent fractions and changing things all around, young students can actually come up with the answers for these quite simply, and they can use some very interesting mental math strategies. And a lot of it's based around the concept of a referent, something that they can compare things to that they have a good understanding from, and they can tell if it's bigger or smaller compared to that thing that they understand. And the referent we're going to talk about is they understand pretty much the idea of not having anything. They understand a 0, they understand having a whole, and they're fairly good at understanding what a half might be. So we're going to use those 3 as reference, and we're going to have our students place our fractions relative to those. Is it bigger than a half? Is it smaller than a half? If it's smaller than a half, is it bigger than 0? If it's bigger than a half, is it smaller than 1? And be able to put them someplace along a continuum between 0 and 1 is what we want to be able to get the students to do. For the 0, if I don't have a pi, can I divide it into equal size pieces? Well, I could divide it into halves, but what's half of something I don't have? What's a third or a quarter of something I don't have? If I don't have it, you can cut it into as many pieces as you like. It's still going to end up being a 0. Over here on this side, if I have one whole circle, it's pretty easy to figure out what I have. I have an entire circle. So over on this side, I don't have any circles at all. Over here, I have a full circle. What would half a circle look like? And kids are pretty good at dividing things in half, and so half my circle would look something like this. So from here we want to make sure that they play around with some of the shapes and try to see where they fit inside of all of this. So if I have 1/4, is 1/4 above a half or smaller than a half? Well, 1/4 is going to be smaller than 1/2, but bigger than 0. So I can put my 1/4 someplace up here. Oops, sorry. I could put my 1/4 someplace up here. It's bigger than a 0, but smaller than a half. Then we go into saying, well, what happens if I had 2 of these quarters? Well, the student can play around with them a little bit and notice that, well, 2 of these quarters is pretty much the same thing as a half. So 2/4 would be the same thing as a half. And if I had 3 of these quarters, well, 3 of these quarters is bigger than a half, so it's got to be someplace on this side. And to get a full circle, I would probably need 4 of these. So 4 of these quarters, or 4 of these things that are size 4, would also be the same thing as 1. So I can start making a little table here and having my 0, my half, and my 1. And I can see where 1/4 fit, where I can see where 2/4 fit, and I can see where 3/4 would fit, and I can see where 4/4 would fit. And you could tie that into money as well: 1/4, 2/4, 3/4, and 4/4. So let's pretend we want to figure out how big an eighth is. Where does that fit on my number line? Well, I know my quarter is over here someplace, and this is my eighth. If I take my one circle and I cut it into 8 different pieces, it fits in here. Well, it's definitely smaller than a whole. It's definitely smaller than a half. It's smaller than a quarter, so it's got to fit somewhere between here, 0 and a quarter. And so we could put our 1/8 somewhere in here someplace. I don't know exactly where it is, but it's somewhere between a quarter and a 0. But a student might play around with this a little bit and notice, well, hey, it takes 2 of these. So isn't that like a half? It's a half of this. So I could put that 1/8 halfway between a quarter and a 0. And they can start talking about things like that. So we can place our numbers and figure out where they might go. Well, if it takes 2 of those to make that, then how much is it going to take to make a whole half? Well, they'll notice 1, 2, 3, 4 of those. So it could come out to being 4/8. And we can come up with the idea that 4/8 is going to be the same thing as my 1/2. And with a little bit more playing around, we could see that if we filled up this whole circle, it would take 8/8 to get that. So where would 5/8 have to fit? Well, 5/8 would have to fit somewhere between 4/8 and 8/8. It would be somewhere in here. Where would 6/8 go? Somewhere in here as well. Again, we don't have to be really specific with it, but we can figure out where they might fit. I know it's more than a half because a half is 4/8. I know it's less than 1 because 1 is 8/8, so I know it's somewhere over here. So if we wanted to compare 1/4 to 5/8, students say, well, I know 1/4 is smaller than half because it's 4/8 is a half, and 1/4 is smaller than that, and 5/8 is more than a half because I know 4/8 is halfway. So 5/8 must be bigger than 1/4, and they don't need to go into any more detail other than that. So when they're working with even number pieces, it's not too hard to find what the halfway point is, but now if we start talking about fifths, it becomes problematic. If I have 0, I have 0/5, that's not too hard. If I have 1 whole, that's 5/5. What would half look like? And it'd be interesting, some students will come up with the idea, well, it's 2.5/5. And that's a perfectly acceptable referent. So it's a kind of a strange looking fraction, 2.5/5, but it's perfectly acceptable. So if I had 1/5 over here, would that be more than 2.5/5 or less than 2.5/5? Well, that would be less. If I had 3/5 over here, would that be more than 2.5/5 or less than 2.5/5? Well, it's more than 2.5/5. So again, we can place fractions above our halfway point, which we figured out as 2.5, and we can come up with a referent, and we can then place numbers like 3/5 and compare them to things like 1/4. And so we have 3/5 compared to 1/4. I know 1/4 is less than half. I know 3/5 now is greater than half, so I know that 3/5 is bigger than 1/4. Now in a question like this, 2/4 and 6/8, it's a little confusing. Some students will be able to say, well, this is a half, and this is 4/8 is a half, so this one's bigger. But other students will be looking for patterns, and they'll say, well, this one's 2 away from this one, and this one's 2 away from this one, so they must be equal. And so then we want to talk about the size of the pieces. I'm talking about I'm 2 away from having a whole one of these, and I'm 2 of these pieces being away from a whole one of these. Which one has more pieces? So if I'm missing 2 of these, then I'm missing a half. If I'm missing just 2 of these, I'm only missing a little tiny piece. So therefore this one must be closer to a whole than this one, even though they're both 2 pieces away. 6 out of a possible 8, 2 out of a possible 4. They're both missing 2 pieces, but they're different size pieces. So again, that idea of what that number in the bottom tells us, talks about size, can be an important referent to help them figure out their comparison. So students can compare fractions without actually having to work with equivalent fractions, but in the process of doing so, they'll start to see some equivalent fractions, especially for their reference, things like 1/2 and 1/2. And next segment we'll talk about making equivalent fractions in a little bit more systematic kind of manner.